Hello guys, this is Deepika Rani. I come up with the new topic called ERD. Before looking into the sublanguages of SQL, we will look into the ERD. Now question arises. What is ERD and is it needy? Yes, of course. Consider a scenario that you are going to design a database for your project. So client asks you that how you are going to design it. So at that instance of time, if you give the document of your design, he doesn't understand anything because he is a non-technical person and he feels that it's a technical jargon. So at this instance of time, you need a tool that it can able to communicate with a non-technical person. So ERD comes up with you and helps you that to show how you are going to design, and that business person can able to understand it. So this is the use of ERD. ERD is nothing but a communication tool between a technical person and a non-technical person, and helps to communicate that how you are going to design your database. So let's start our session on ERD. So what is ERD means? It's an entity relationship diagram. So it is a tool to represent the analyzed data in a graphical or a diagrammatic form. So the graphical representation of ER model is nothing but an entity relationship diagram. So it is a blueprint for the database design. So it's a template for database design. Before going to design, before going to implement your database, it is needed to represent it on a paper, or if it is needed to design or to give a blueprint for it. I think you understand what the ERD means. It gives a clear picture of the structure of your database. Okay, this is an example of ERD. So in this way you have to represent you have to represent the design of your database. So what this means, it contains some rectangles, some diamonds, some oval shapes and so on. So we will see all these things one by one. So the components of ERD contains entities, which is represented in rectangular box, an attribute which is represented in oval shape, and relation which is represented in diamond symbol. So now question arises, what entity means? Entity means it is nothing but an object that exists in the real world. It can exist either physically or logically. So what exactly it means, consider a scenario that a patient want to get treatment from the hospital. So he entered into the hospital and registered all his details. So at this instant of time, we are collecting the data from the patient, right? Like his name, what his disease, and what his age, and all those things. We are collecting the data from the patients. Here the patient is an entity and exists in the real world, right? This is nothing but an entity. Okay, again these are two kinds, that is physically or logically. The existence of this thing, that is this object, either physically or logically. Physical things are tangible, that is we can see it, we can see them. Those objects we can able to see. So some of the examples are students, hospital, employee, patients, and so on. That is, we can see them, we can see the student, we can see the hospital, we can see the employee, like that. Then what is logical? Logical things are nothing but which is intangible and we can feel them. So some of the examples required for this, right? So those are nothing but bank transactions, we can't see them, but we can feel. Bus bookings, and these are nothing but some services kind of things. um, Bank transaction also, some of the things like to whom you are going to give your money, how much amount of money, you can collect all those things, right? So bank transaction, bus bookings, all those are intangible and those are logical things. Then how can we represent these things in the entity relationship diagram? That is this rectangular box. Rectangular box is nothing but an entity, that is an object that exists in the real world. Now we are clear with what entity means. Then we enter what attribute means. Attributes is nothing but characteristics or properties of the entity. So let's consider that we are collecting the details of the patient, right? What are the things we are going to collect? That is his name, his age, his disease, and all those. Those things are nothing but characteristics or the properties of the person, that is that entity. So those are denoted with the help of vowels. Some of the examples are patient entity have DOB as attribute. DOB is nothing but date of birth as an attribute. So we will represent the thing in vowel shape and this way. Inside the vowel shape we write what that characteristic, what that property is. Now we are clear with what the attribute is. Next, we have different kinds of attribute with us. Those are simple attribute and composite attribute, single valued and multi-valued, and so on. We will see one by one. What the simple attribute means. Simple attribute means we cannot divide that attribute further. Then what is composite attribute? We can divide that attribute further. Okay. Now DOB is one of the example of simple attribute and name is one of the example of composite attribute. Here name is an attribute. We can divide this name attribute to subparts like first, middle, last. For DOB we can't divide this attribute further. So these two are the one kind of attribute. Then we have single valued and multi-valued. Okay. What the multi-value means, for that attribute we can store more than one value, then we term that value as multi-value attribute. And then single value means we can store only one value, we can't store more than one, then we term that attribute as single valued attribute. So we require some of the examples, right? So see, this is single valued attribute because we have only one date of birth. We don't have more than one, right? For multi-value, we have phone number. We have more than one value, more than one phone number. So that's why I represented this thing in double ellipse. This double ellipse depicts that these attribute have more than one value. This is one kind of symbol. Next, we will see derived attribute. What the derived attribute means, we can get the value of that attribute from the another attribute. We require some example again. It is represented in dotted oval, and age is the example of derived attribute. It can be exists, or we can get the value of age from the date of birth. So date of birth is actual attribute, and with that help of attribute we can extract the value of age. So this is the derived attribute. Then what is primary key? This is nothing but it is we can uniquely identify that entity with the help of this attribute. Then that attribute we termed as primary key. It is represented with this symbol, oval shape with underlined. Consider patient ID is an attribute. With the help of this attribute, we can uniquely identify that object or that entity. So these are the types of attributes in ERD. Next, types of entity set. So then we have weak entity and we have strong entity set. So what is weak entity then? An entity which does not have its own identity, then which is represented in double rectangle. Mm, we need some example, right? So the entity set, the entity which we cannot which we cannot identify uniquely, which does not have any primary key with it, then we term the thing as weak entity. Then what is strong entity then? An entity which does have its own identity, which means it has some primary key with it. It is represented in normal rectangle. So double rectangle means it is a weak entity, and single rectangle means it's a strong entity. So these are the types of entity set. Let's see what the relationship. Relationship means it's nothing but association that describes the interaction between the entities. We have one entity here and the another entity here. Now what we need to do is this entity wants to communicate with this entity with the help of this relation. Uh, it has certain relation that these two are have some relation. So this is represented with the help of diamond symbol and with the connected lines. We have cardinality constraints. Those means we have hospital entity with us and doctor entity with us. So hospital entity have some certain objects, right? So we have A hospital, B hospital and C hospital for example. And for A hospital we have so many doctors, like so many objects we have. We have more than one doctor exists. For each hospital, we have more number of doctors, that is greater than 1. For each doctor, he belongs to one hospital, right? So cardinality represents that thing. Here 1 means for one hospital, we have more than one doctor. For one doctor, we have one hospital. This is the meaning of this diagram. See, cardinality represents number of the instances of one entity can be related to one instance of the another entity. How it is related, we can represent it with the help of this cardinality constraints. Cardinalities are one to one, one to many, many to many, and it is denoted with the help of Crowfoot notation also. Okay, we see here it is one to many. For suppose we have many hospitals and we have only we have many doctors, then this thing goes to many relationship. For one to one relationship, we have only one hospital and we have only one doctor. This can be exists when it is a startup hospital, right? So this way we can represent the relationship with the help of cardinalities. Fine. And these are the types of cardinalities, and this is the notation we actually use. Okay, now understand the example of ERD. Okay, fine. Till now what we know is what is entity means, what is relationship, what is attribute. We consider a scenario that we are going to design the hospital database. So we have hospital. For hospital we have some doctors and patients. For hospital we have hospital name, we have hospital address, we have registration number too. So hospital is an entity which exists in the real world, and this hospital has certain characteristics. Those are hospital name and its address and its registration number. So that's why I represented those things in these oval shapes. Nothing but attributes of this hospital. Okay, we have doctors also. So doctor have name and specialization. So name that can be further divided, right? So that's why I represented as first, middle and last. Okay, some specialization we have. After that we have patients. Patients have ID, name, phone number, date of birth and age. Okay, ID is a primary key. So that's why I represented that attribute like this. And name, we can further divided this name, that is subparts, first name, middle name, last name. So that's why I represent this attribute in this way. Compound attribute, right? And this phone number have more than one value. So that's why I represented this thing in double edits. So this is a multi-valued attribute, right? So DOB is simple attribute and A is derived attribute from this. So now we are clear with patient, doctor and hospital. Now how these things are related is represented with the help of relationship. So hospital has doctors and patients get treated in the hospital. This is the thing represented in this ERD. ERD. I think you are clear with what the ERD means. Thanks for watching. If you like this video, please like it, share it, and subscribe our channel. Thank you.